Hello, this is a video to show you how to use Google Sheets to analyze the data from the Pendulum lab. If we go to Google and we sign into the account, we can go to Apps and click on Sheets, click on Blank. We now have a blank data sheet. My screen is zoomed in, so yours may be looking smaller, something like this. But I'm going to zoom in to make it easier for you to see what I'm doing. I'm using Control plus and minus to zoom in and out. Let's give this a title. We're going to do this in the form of a memo. So I'm going to type in Inter-Office Memorandum. I'm going to increase the font to 14. Put a line underneath it. Using the borders. In one column I'm going to put 2, and yours will be addressed to me, but I'll just mimic what you will be doing. From. You can put your name here. Subject. Here we want to put the subject of the memorandum. Perhaps something like Pendulum investigation data. And we can put the date. And typically, if you're going to CC anybody, you can put them right here. Let's underline that by selecting the cells and going to borders and underline. Going to create a section here called data. We're going to increase the font to 13. And the first thing I'm going to enter in are my measurements with the 20 gram pendulum bulb. So my first column will need, the header will have different layers, so let's give ourselves a space of about 4 columns here. And let's start off. The first column is going to be the length of the pendulum. And the units for that are meters. I want to wrap the text. So I will go to text wrap, which is this one. Make sure it's turned on. And you see the text is wrapped. And the height of the row has increased. Here I'm going to type in the columns for the repeats. So we've got run 1, run number 2, run number 3, and we're going to calculate the range and of course the average value. And this will be in seconds. Looks like that's not wrapping, so I will select the whole row by clicking on the left cell right here where the number is. That selects the entire row, and I will make sure that text wrapping is on. Very good. Here I will combine these and say this is the time for 10 oscillations. So this is the data that we collected. I'm going to merge these 4 cells here by selecting them and going to merge. I'm going to center and put a line underneath. And that's looking good so far. I'm also going to calculate a column here called the average period squared, and that will be in units of seconds squared. Going to select those cells, put a line underneath by going to borders. So here I have my blank table. I'm going to start with a length of pendulum of 0. Next one was 0.2. If I select these, I can drag this down until I get, and basically creating a series with steps of 0.2. So you don't have to type in the numbers of a series. So we've got the different lengths that we tried. The 0 we didn't try, but that's a theoretical value. Theoretically, a 0 length pendulum should take 0 time. So those are theoretical. Now, here you can enter in your data. I'm going to put in my data. I got 9.1 for the period of 10 oscillations, or the time for 10 oscillations, with a pendulum length of 0.2 meters, which is 20 centimeters, with a 20-gram pendulum bob. When I repeated it, I got 9.5, 9.2 for the third one. I'm going to enter in my other data similarly. Please use your own data. Okay, so we went into our experimental data. Going to select the bottom row and put an underline. Now I'm going to calculate the range. This is equal to the maximum value. So I put in max and open the parentheses, and then I'm going to select these 3 cells. And you see the address here. This is B17 all the way to D17. So these are the cells that are going to be put into the max function to find the maximum value. From the max value, I will subtract the minimum value for the same data range. When I press enter, it is automatically calculated, and it's asking me whether to autofill that equation for the other rows. It will update which rows it is calculating the range for accordingly. So I will select yes, and I will underline that last border. Now we can see if I click on row 18 and we look at the formula. So I'll double click, and you see this formula is the max of these 3 cells on row 18 minus the min of these 3 cells on row 18. So it has used what's called a relative referencing to make sure that we perform the same operation for the correct row. Okay, so now we're going to calculate the average period. We're going to use the average function. So to use the function, you press equals, put the name of the function, and you see it's helping us with hints. And we want to find the average of just these 3 results. Close the parentheses, press enter, and we can accept the autofill. Let's fix the border, and let's have a look at these results. They do look reasonable. Let's go here and update the range, make sure it says seconds. Here we've got 2 in decimal places, so you can select these cells and you can use this tool here to reduce the number of decimal places. that's too little. Let's do 2 decimal places. Now we can calculate the square. So we'll do equals. We select this cell and we use the caret because we're raising to the power 2. Press enter. We can use the autofill. Okay, so I just realized I made a mistake and I'm going to fix it. And it's going to illustrate something. So what I forgot to do was to divide this number by 10. So what I'm going to do, I'm going to select, double click on my cell to open up the equation, and then I'm going to divide this by 10. Then I'm going to drag that down, fix my border, and you notice that because this number was updated, the squared value was also automatically updated. Let's correct the number of decimals. And now we have completed data the calculations for the 20-gram pendulum bob. We want to do the same for the 10-gram pendulum bob. It's going to be very similar. So I'm selecting these cells, pressing Ctrl C to copy, Ctrl V to paste, and then I'm going to update this to say 10 gram. And I'm just going to put my new numbers in. And the other columns, such as the range, the average, and the period squared, the average period squared, will be updated accordingly. So I'm putting in my numbers for the 10-gram pendulum. And you'll notice the other numbers are being updated accordingly. Okay, so now I'm just going to zoom out so it will look similar to what you have. So you may have something that looks like this. Okay, so the next thing we can do is create a summary. So summary of average pendulum periods. And we can increase the font size to match the previous section header. So use 13. Here, my first column is length. I'm going to start with 0.2, my actual experimental data, because I want to compare the changes in the period caused by the change in the experimental variables. So we have length in meters, and now for the 20-gram bob, I'm going to put the pendulum period here in seconds. So I'm going to put 20-gram bob pendulum period, or you could put the full name, which is the average pendulum period, in seconds. I'm going to select the entire row and make sure the wrapping is turned on. There we go. If you like to make it look nicer, you can center. So I'm going to select all of that and center. Okay, so what we can do, we can take this data here for the 20-gram bob. I'm using Ctrl C to copy. And this time I'm going to right click and I'm going to paste special. I'm going to paste the values only. So this way the formulas, if we paste the formulas, they will be looking in the wrong places for the data. So let me just show you what happens. So if I do Control V, you'll see that we get an error. That's because the formula is looking for information that it doesn't have. So what we want to do, you see in this location the formula doesn't make sense. In this location it does, because it's looking at the cells that are towards the left in this location, but there are no such cells towards the left in this case. So what we can do is we can go over, select these cells, using Control C to copy, right click and use paste special and paste values only. I'm going to I'm going to copy this, I'm going to paste, Control V to paste, and this one I'm going to update the column header to say 10 gram. And now I'm going to go over to my table for the 10 gram pendulum bob, Control C to copy, right click and paste special, values only. What I'm going to do is just change the decimal places there. There we have it. Okay. Excellent. So now we have this, we can do a little bit of analysis here. We can say, what is the change in period due to the change in pendulum mass? Okay, so what this is we are going to take this, we're going to subtract the value that we get for the 10 gram bob from the 20 gram bob. So first, if I press equals, select this cell, we see it's going to equal this cell, and I'm going to do minus the other cell that I want to subtract from it. So now we've got the equation in there, pressing enter, and we see that we've got it's actually, the rounding error doesn't show it, but we've got a 1/100th of a second drop. Let's do the other. So we have a drop for that one, and a drop for the other two. Actually an increase for this one. It's hard to see because the decimal places aren't shown. But in any case, we should also put the units here. This is in seconds. Now we can calculate the change in period due to the change in length. Again, that's going to be in seconds. And here, we don't have anything to compare to for the first result, so I'm just going to put a dash. And I'm going to center that. Now here, I'm going to say this is equal to this value here minus this value. So we're looking at the change in period that occurs when you change the length. Going to autofill that down, and this column only applies for the 20 gram bob. So we see that when we double the mass, we only change the period by a few hundredths of a second. We compare that to our range. Our range is 0.3 of a second for 10 readings. So our range, our spread within the repeated measurement is about 0.03 of a second. So these differences would be then considered not significant, because the differences caused by the change in pendulum mass is smaller than the spread of values when we keep all parameters the same. We see here that we're getting bigger changes that are unlikely to result from just simple variation in between measurements when we repeat under the same conditions. So this summarizes what influences the pendulum period. So let's just make this look a little bit neater. So we can put an underline on the top, we can underline the bottom. And that looks okay. We could perhaps center, like so. Okay, and that looks okay. So the next thing we're going to do is to create some graphs. Now we have our data input and our average period squared calculated. We are now ready to plot the graphs. To plot the graphs, I like to click on an empty cell to make sure when I insert a cell, I'm going to get an empty graph. I'm going to click on Insert. I'm going to zoom in here. Click on Insert, click on Chart. From the drop-down menu, I will select Scatter Chart. And then for my x-axis, I want to select the pendulum length. So I'm going to click into this data entry cell. And on the table for the 20 gram pendulum bob, I'm going to select the values for the pendulum length. Press OK. Notice that I did select the header as well, and this will mean that the x-axis is automatically labeled from the header. Next thing, I will add a series. I'll click on Add Series. Click on the Select Data Range icon. Put my cursor inside the box. Move over and select the column there, my column values, including the header for the average period. Click OK. And we have a graph. I will zoom out now. Here's the graph. We can select it and drag it and move it to a new position. We can also size it accordingly. If you've lost the editor box, you can click on the graph, click on the three dots on the top right hand corner and select Edit Chart. What we'd like to do here now is we'd also want to plot on this graph the average period for the 10 gram pendulum. So we can click on Add Series, click on the icon to select a data range, put your cursor inside the box, look at the data for the 10 gram pendulum bob, select the header and the period values for the 10 gram pendulum bob, select OK, and now we have both data points. You'll see here that it's hard to distinguish which is which, so we can go over here and we can change the header to include 20 gram bob, and you see that's going to appear over here. And let's do the same thing for, actually I did that wrong, this is for the 10 gram bob, so let me just correct that. And above here I'm going to put a little note there. That's for the 20 gram bob, and there's no need to capitalize the B, so I'm going to change that to just bob. There we go. Okay, so now if we look on our graph, we'll see the data points can be distinguished. They pretty much lie on top of each other. Now we have this. Let's change a few more things. Let's edit the chart and let's customize. Go to Chart Title, Axis Titles, Chart and Axis Titles. Let's label the vertical axis, this one here. The vertical axis is going to be that's our pendulum period. Always have the units, that's in seconds. Now let's, from the drop down box, let's select horizontal axis title, and that is the pendulum length. That's going to be in meters. That looks good. Here on the legend, we can change the position of this legend. I would like to put that at the bottom, like so. I want to go back to the chart and axis titles, and from the drop down box, put in chart title, and now I'm going to give my graph a title. I'm going to call it variation of pendulum period. This is actually the average pendulum period. With pendulum length for pendulums with different masses. I'd like to center that, so I can select center from here, and I'm happy with my graph. I'd like to know what kind of curve this is, so I'm just going to double check that this is okay. Yep, that's okay. I'm going to go back into my edit chart, go to customize, go to series, and down here I'm going to select trend line. Now you see the straight line doesn't really make sense because a zero length pendulum should have a zero period. So we can change the type of fit, and you can go through. Exponential also doesn't make sense. It doesn't go through 0, 0. The polynomial does make sense, maybe unnecessarily complicated. The logarithmic doesn't make sense, doesn't go through 0, 0. Power series, actually this is the best one, but it doesn't extend down to here. Theoretically this is the best one. And we can show the equation right there. Okay, and so we have that. You can also change the grid lines and ticks if you like down here, but everything looks pretty good to me. So we've plotted this graph. The next graph that we're going to plot is just looking at the 20 gram pendulum. Going to look at the average period squared as a function of the length of the pendulum. So once again, I'm going to click on empty cell, insert a chart, move the chart to a new location, select the type of chart I want, which is a scatter, add my x-axis. My x-axis is the average period squared. Select my y-axis now. Actually, I think I did that the wrong way around. Yes, I did that the wrong way around. So let me cancel that. So here, let's go back to the x-axis and remove. Let's add the x-axis again. But this time, we're going to use the length of the pendulum for our, let me make sure, for our 20 gram bob. So gonna click on there again, select a data range, put my cursor in the text input box, select this column. Okay, that's my x-axis. My y-axis, that should be the average period squared. Let's see our graph. Okay, that looks pretty good. Now we can customize it. We can, looking at chart and axis titles, use a drop-down box to select chart title. give it a title. So this is variation of average period squared as a width, or you can do with pendulum length. For a pendulum with a 20-gram bob. All right, and we can center that title. Let's label the horizontal axis title. Let's do that. So the horizontal axis is going to be our pendulum length. Our vertical axis is going to be the pendulum period squared. That looks good. And go into series, we can add a trend line. Looks like a pretty good fit to a straight line. So it's the linear fit. And going to label here, I'm going to display the equation. Then I'm going to go to legend, and I'm going to put my legend at the bottom. So all that data is at the bottom. And that looks good enough for me. So this is telling us that the pendulum period squared is a linear function of the pendulum length. This is the equation of the line that is the best fit to the experimental data. So let me zoom in on that. Right there, that's the equation of the line that fits our experimental data. Let's use the fitted equation to determine the mass of the Earth. So let's start a new section. Call that mass of the Earth. Let's increase the font size to 13. Make it consistent with the other headings. And what I'm going to do here, I'm going to download this PNG file, which contains the equations that we are going to use to determine the mass of the Earth. So that's in my downloads folder. And then I'm going to insert an image, and I want to insert it over the cells, and I am going to upload, so browse, mass of the Earth here. And here we see the equations that I've imported into it. And let's take a look at these equations. So this equation here is from the lab manual, the first one. If we square both sides, we can see that t squared, the period squared, is equal to a constant multiplied by the length of the pendulum. So this is an equation of the form y equals mx plus c, where y is the t squared, x is L, c is 0 in this case, there's no constant, and the gradient here is going to be this value, this constant, which is the value of the constant is dependent upon the radius of the Earth, the mass of the Earth, and the universal gravitational constant. We can see that m is related to the mass of the Earth by this equation. If we rearrange for the mass of the Earth, we can determine that we could actually calculate the mass of the Earth from m, which is the gradient of the curve, or the gradient of the line between t squared and L. And this over here, let me just zoom out. Zooming out again. Looking at our graph of t squared in seconds versus pendulum length in meters, we see it's a straight line. The equation of the line is 4.51 times x plus minus 0.014. So we have a very a small value for c that may be due to experimental variations. Ideally, this result would be 0. So we're going to neglect that term and just look at the gradient, which is 4.51. So we can plug this 4.51 into the value for m and calculate the mass of the Earth. For that, we need some constants. So let me zoom in again. Radius of the Earth. So we can have a cell. I'm going to just increase the width of the first column so we can fit that in. And that is given in our notes as, let me just show the notes over here. And we see it is given as 6,380 kilometers. So let's go back and put 6,380. Now we want that in meters, so we have to multiply that by 1,000. Another way you could do that is multiply by 10 raised to the power 3, and you can do that by doing E3. Press enter. And you see that's equivalent to 6.38 million meters. And here I'm going to put the unit meters. Okay, so what's the other constant that we need? We need G, the universal gravitational constant. And going back to our notes, just excuse me, let me just okay, we'll just go with this. But the universal gravitational constant is 6.67 times 10 to the minus 11. So let's go and put that in. That's 6.67 e to the minus 11. And the units for that are, excuse me one second, let me just click away. There we go. So the units for that are meters cubed per kilogram per second squared. So I put the units in right there. Okay, well, let's now calculate the mass of the Earth then, based upon those constants and our value of m. So we're going to create an equation. I'm going to zoom in here so you can see what I'm typing in. Maybe I just want to go a little bit less. There we go. So equals 4 pi squared. So here we go equals 4 times. Now we can use a function there, pi squared times re squared. So this is the radius of the Earth, so I'm going to click on this cell and square that. and then divide it by. So what we want to do is divide that. We're going to have to open parentheses to make sure the order of operation is correct, times G. So let's click on the cell for G and multiply that by M. M is the value of our gradient in our graph, which is 4.51. Going to close the parentheses and press enter. Ooh, so what's happened here? Oh, it doesn't like pi. So we may have to put an open and close parentheses like so. Okay, and because pi is a function. And now we have the answer in kilograms. So here we've shown how to analyze the data for the pendulum experiment using Google Sheets, and at the end calculate the mass of the Earth from the graphs that we've created. Thank you.